Welcome back to the second session.
Morning, ma'am.
Okay, good morning. I remember I had given one question for you in the morning to do it. Okay.
Yes.
Okay. Shall we do it? Did you finish
Yes,
it? Did you finish it? Children, did you finish it? Yes or no? Nobody has done it. Very bad.
No, ma'am.
Who finished it? Ashik came back. Okay. Morning you were not there, Ashik?
Ma'am, power failure.
Power failure was there. Okay. So, how many of you have done it? Anybody got the answer? No problem, no problem. It was some tough question. I'll give it. I'll explain now. I will explain it now. Shall I?
Yes, ma'am.
Yes, ma'am.
Okay, I'll explain it. No problem. If you did not get also, no problem. It was a little bit tough question. But when you write the first step, it will be easy for you. Okay, I'll explain it. See. Okay, our question was, I'll write the question and tell me is it correct or not. Okay, our question was 25. Is this the same question? Is this the same question?
Yes, ma'am.
Okay, 25
Yes,
all to the power of negative 1 by 3, all raised to negative 1 by 3 into cube root of 16. Cube root of 16. So you have to use the law of exponent. Not one law, you have to use 2 or 3 laws together to get the answer of this question. Okay. And which law we are using here? When you see it, you are seeing cube root of 16 first. Cube root of 16. If you are writing that, it will be easy for you. Correct? Yes?
Yes, ma'am.
Okay. Cube root of 16. How will you reduce that cube root? Cube root. It is cube root of 16. Which law you are using? Tell me the laws. Tell me the laws we are using here. First, cube root of instead of
root of a is equal to
very good. Nth root of a.
Nth root of a is equal to 1 by a.
Nth root of a equal to a raised to
1 by n.
1 by n. Good. A raised to 1 by n. A raised to 1 by n. This is the law we are using here. Fine. And cube root of 16. We'll write cube root of 16 as cube root of 16 as cube root of 16 is 16 raised to tell me the answer.
1 by 3.
1 by 3. Wait. So cube root of 16 we will write as 16 raised to 1 by 3. No need of doing anything there. But you see this 25 raised to negative 1 by 3. It is negative 1 by 3. I'll show it again. So I'll move the board. So here 25 raised to negative 1 by 3 is already there. And you made that cube root of 16 as 16 raised to 1 by 3. 1 by 3. Here, see this. It is, you cannot use the law of exponent since the power is not same and base also not same. Rifa. Okay. Power is not same and base also not same. Okay. Either you make the power same or you make the base same. Okay. You cannot make the base same because it is 25 and 16. There is no way to make 25 and 16 same. But you can make the power same. Okay. In order to use the law of exponent, you can make the power as the same number. Correct. So it is negative 1 by 3. How can you make it as positive 1 by 3? Is there any way to make? Is there any way to remove that negative sign from the exponent?
Reciprocal.
Reciprocal means
3
25.
by 1. 25 raised to 3 by 1.
1 by
Exponents
25.
reciprocal will not change. So that is a big mistake you are making. Exponents reciprocal we are not writing. There is no law of writing that exponents reciprocal. The number, the base, we are writing the reciprocal upside down. Okay. Numerator as denominator, denominator as numerator. See, listen. If instead of writing 25 raised to negative 1 by 3, I can write 25, 1 by 25 raised to 1 by 3. Is it? You cannot change reciprocal. You cannot write exponents reciprocal. Okay. Exponents upside down we are not writing. We are writing the base. Base reciprocal only. If it is 3 by 5, we are writing 5 by 3. If it is simply 25, we will be writing 1 by 25. But remember, exponent is always same. We can write negative and positive. When you shift to upside up and down, negative and positive will come. Okay, let me explain it. I hope you did not understand it. I think you did not understand. Okay, listen. Just now somebody told me, you can write negative 1 by 3 as 3 by 1. We are not touching the exponent now. When we use the law of exponent, that exponent's reciprocal we will not write. Number we are changing. I'll write it again. See. Listen. Can you see the board now? Can you see?
Yes, ma'am.
Okay. Listen carefully. If 25, our question is 25 raised to negative 1 by 3. How will you remove that exponent's negative sign?
1 by 25 raised to
base
minus 1 by 1.
reciprocal we are writing. Base reciprocal. Exponent reciprocal is same. Fraction is same. Only that we are removing the negative number. Okay. And if it is 3 by 5, all raised to negative 1 by 3. How will you write? 5 by 3 all to the power of 1 by 3 only. In this both the cases 1 by 3 remains same. There is no rule to make it as 3 by 1. Clear? Is it clear for you?
Yes, ma'am.
That 1 by 3 remains same if you are writing the reciprocal of one number. There is no law of exponent to make 1 by 3 as 3 by 1. Okay, exponents remain same. Whenever you are using, you are shifting upside down. Only the negative will become positive and positive will become negative, only that. But the numbers reciprocal you can write, base reciprocal you can write. I hope you understood. Okay? Did you understand it? So, I don't know which student told the answer, but I think she understood it. Can I proceed?
Yes, ma'am.
Ma'am.
Yes.
Can you show it again?
Which one?
That question's last step.
This one means this. This you are telling? This.
Yes.
Okay, okay. Okay, the same. I did not see, I did not finish it. In between, I went for explaining this. Now you see, 25 all to the power of negative 1 by 3 raised to negative 1 by 3. How will you write? How will you write? Use the law of exponent there. 1 by 3 never changes. Sign only changes. When it go up and down, numerator and denominator, 1 by 3 remains same. Clear? Clear? Adidev?
Yes, ma'am.
Okay. See, 1 by 3 remains same. 25 is reciprocal. Base reciprocal only we are writing as 1 by 25 to the power 1 by 3. Now just see, it is instead of 25 raised to negative 1 by 3, we wrote as 1 by 25 raised to 1 by 3. But here 16 is there. 60 raised to 1 by 3 is there. Now in a single step, how can you write? In a single step, how can you write it? This is our question. Answer. What will you write as the next step? What will you write as the next step? 1 into 60
5
raised to 1 by 3.
square.
1 into 60, will you write it as a single step? See, listen. It is 1 by 20, 25 is there in the denominator and 16 is there in the numerator. Okay. So it is write it as a single fraction. How will you write? 60 raised to, shall I write? 60 raised to 1 by 3 by, are you listening? Are you
Yes, ma'am.
following me?
Yes, ma'am. Yes, ma'am.
Okay. 60 raised to 1 by 3 divided by 25 raised to 1 by 3. Is it correct? Did you get the answer?
Yes,
Did you
ma'am.
get
Yes,
step? Did you
ma'am.
get? Okay. Now the power is same. Now the power is same. Power is same. Which law you will use here? A raised to m divided by which law?
A raised to m divided by b raised to m.
Very good. A raised to m divided by b raised to m. Power is same and you will write as a by b all raised to m. So this is the law. So we reduced the answer steps to come to this law. Okay. Now it is 16 by 25 all raised to 1 by 3. Okay. Only this. We cannot do anything because 16 is either you can write 2 raised to 4 or 4 raised to 2. 25 is 5 raised to 2. Okay. If it is a cube third power, it is easy for you to reduce it. But here only this much is our answer. Shall I explain it once again? I'll explain. Listen. See, this is our question. This is the question. First step, we wrote 3 raised to cube root of 16 as 60 raised to 1 by 3. When we substituted that 60 raised to 1 by 3, here it is 25 raised to negative 1 by 3. It is there. You have to make the power same, base we cannot make same because 25 and 16 are entirely different number. So make the power same. We reduced negative 1 by 3 as positive 1 by 3 by shifting that number to denominator. So it is 1 by 25 raised to 1 by 3 into 60 raised to 1 by 3. Now make it as a single fraction. 60 raised to 1 by 3 by 25 raised to 1 by 3 already there in the denominator. Use the law of exponent. Make it as a single power. This is the answer. Okay. Now, next one. Yes. Yes. Next. No problem. No problem. You got the answer correctly, right? Did you get the answer?
Yes, ma'am.
Same answer, okay. Now, our next topic is rationalization. It's a very important topic, rationalization. So, this last 2-3 days, we were talking about the prime factorization and law of exponent. Isn't it? We were talking about the prime factorization and the law of exponent. Now, today onwards, this period onwards, we will start with another new topic, entirely different. It is rationalization. And this rationalization, you need it for your higher studies also. If you are going for 10th standard, if you are going after 10th standard, if you are going for any other mass related courses, rationalization is needed there also. So it is a very, very important topic, rationalization. Before starting rationalization, we have to brush up our identities. 8th standard, we have studied about the identities. Do you remember the identities?
Yes, ma'am.
Identities.
Yes, ma'am.
Yes, ma'am.
How many identities we studied? Algebraic identities. Yes, children?
Six.
Yes?
Six.
6 identities. What was the first identity we studied? Yes.
A raised to n,
Yes,
plus
yes.
A
b
plus
whole
A plus B whole square. A plus B whole square. Then
a minus b
A
whole
minus B whole
minus B
square.
whole
whole
square.
square.
Okay. So just I'll give a recap of those things. Otherwise, we cannot do the rationalization. If you are not familiar with that, identities, only we can use the rationalization in this topic. Okay. So let me give a quick recap or a brief explanation of the identities. So our first identity is, our identity is, our topic we write first. Our topic is rationalization. Rationalization. Take your notes and write the topic, rationalization. Rationalization. Write the topic. Okay, new topic. It is a new topic, but it is easy. It is interesting and easy also. Okay. Before starting the identities, let me give you one information about this rationalization. Actually, when we indicate like this, root 8, this root is known as radical sign. This is a radical sign, radicals. Okay. And this root, this notation, this simplified form, it is known as, symbol is known as, root is known as radical. And root 2, root 3, root 8, root 7, etc., which all things you are writing, it is known as surds, S-U-R-D-S, surds. Okay, I'll give the detailed notes to you. This square root notation is known as radical sign. Okay, radicals. Now, you know that these all radicals, okay. Now, you know that root 1 is plus or minus 1. When the starting of this chapter, I already told about this root signs. Root 1 is plus or minus 1. And root 4 is, can anybody tell what is the value of root 4?
plus or minus
2.
Very good.
plus or
What
minus
is root 9?
plus or minus 3
Okay, what
Plus
is root
minus 3.
16?
plus or minus 8
Okay. Okay. You know it. Now, let me teach you one important topic, one important thing. When it's very small, you can understand it. Okay. See, root 16, you already know it is root 16 is, can you see the board? I'll change the color of the pen. Okay. This root 16, you already know it is 4, plus or minus 4. Or you take symbol 4. Okay. Now, if it is root of some other number, suppose if it is root 50, you have to reduce that root 50 into some radicals, means into some more simplified form. And it is useful for you. Always it is useful. It is very useful for you. Okay. So root 50, you should make root 50 as a number into a square, perfect square. A multiple of a perfect square. Can you write root 50 as a multiple of a perfect square? Can you write root 50 as a multiple of a perfect square? I don't know whether you have studied it in your previous classes or in the small 8th standard. You might have studied. Root 50, you have to write a perfect square into something. How will you write?
2 into 5 raised to 2.
Think. How will you write root 50? How will you write root 50?
2 into 5 square.
And that is, you mean this 2 into 25?
Factorization.
Yes, ma'am.
It is 2 into 25. Now, you know it as root 2 into root 25. You can make it as 2 roots. Reduce into single root, you make into 2 separate roots. Okay. Root 2, you don't know what is the answer. It is 1.414. But 25, you know. What is root 25? What is
5.
root 25?
Minus or plus 5.
Now you take only positive in these cases. So it is 5. So root 50 is 5 root 2. Value of root 50 is 5 root 2. Did you understand? So root 50's radical form is 5 root 2. Did you understand it?
Yes, ma'am.
Once more I'll explain. If you get any number, square root of a 2-digit number or a single digit number, 8, you can write it like this. So a square root of a single digit, 2-digit number, if possible, for the simplification, for calculation, to make simplify, you can reduce root 50 into, you can reduce root 50 into a very simplified form. For that, which all number you got in the inside the root sign, try to make it as a combination of a perfect square and a number. And okay.
Hello. You. Ma'am,
Okay, children. See? See, it is very easy. It is very easy to make, if it is a 2-digit number or a 3-digit number, to make it simplify, or if you want to simplify it for further calculation, inside the root, the number, you have to make a combination of a ordinary number and a perfect square. Okay, I'll do it again. Okay, it will take time to come. Okay, so this was the question. Can you see the board now? Can you see the board now?
Yes, ma'am.
Okay, so root
Yes,
50,
ma'am.
root 50 you are writing as 2 into 25, and make the root separate, root 2 into root 25, because it is multiplication, you can make it separate. So root 2 into root 25, root 2 write like that itself as a third, as a radical, you write like that itself, repeat it, then root 25, you know the value, it is 5. So it is 5 root 2. Can I give one more question to you? One more question I'll explain. Excuse me.
Yes, ma'am.
Are you listening? Okay. So,
Yes, ma'am.
second example is,
Yes, ma'am.
okay, second example. Second example is, how will you write root 75? How will you write root 75? Are you familiar with these type of questions? Yes or no? Respond.
Not that.
No, ma'am.
No, ma'am.
No, ma'am.
Okay. So root 75, how will you write? A combination of a perfect square and an ordinary
5
number.
square into 3.
3 into 25.
Very good, very good. So it is root of 25 into 3. And make it separate. Root you can make separate. Root 25 into root 3. So, what will be the answer? What is the answer?
5
5?
5 root 3.
5 root 3. Good. Then, next question. We'll go to the next question. Third question. Third question is, it is root 32. Even if it is not a perfect square, you can make it simplify.
16 into 2.
Very good, very good. 16 into 2. Are you following? Rosebi, Nas?
Yes, ma'am.
Okay, it is root.
Yes, ma'am.
Okay, 16 into 2. Now you got the idea. And answer is? Next step also you write root 16 into root 2.
16 root 2.
Root 18 and root 2.
Or root 2.
4 root 2.
4 root 2.
Very good, 4 root 2. It is useful for you for any of the further studies. If you are going 10th standard, it is very useful to simplify. Okay. So when you study the trigonometry functions, the simplification always needed. I'll give the fourth question. Fourth question is, root of 72. Root 72. Root 72. Fast.
9 into 8.
9. Make it perfect square when you select. You make the maximum big number, means large number.
At
Don't
36.
select the small. 9 also you can do. But select the large number, large square, so that you can simplify it more easily.
Root 2, root 3.
Math 36.
Very good. Very good. So root 72 is 36 into 36
Two.
into 36 into
2.
and
Two.
it is root 36 into root 2. Now what is answer?
18 root
6
2.
root 2.
Root 36, who told that it is 18?
Sorry,
root
ma'am.
root 36 it is?
6 root 2.
Okay. 6 root 2. Fine. Next question. Very simple question and very useful also. Next question is, I'll move the board. Fifth question is, fifth question, root 8. This root 8 we are using always. Root 8 we'll use always. Yes. Do it. It's very easy.
Two into 4.
Yes.
2 root
Yes.
2 root 2.
Very good. 2 root 2. Can you explain the steps to me?
Root 2, root 3.
Root 2, root 2.
Root 4 into root 2.
Root of
2 root of 4.
4 into 2.
Root
Root 4 into root 2. What is root 4?
2.
So it is 2 root 2. I hope you understood this. Okay. Did you
Yes, ma'am.
understand this?
Yes,
So
ma'am.
it is
Yes,
very
ma'am.
easy and it is very useful.
Yes, ma'am.
Yes, ma'am.
Okay. Shall I wind up the class today? Today
Yes,
I will
ma'am.
send the notes to you. Today
Okay,
I will
ma'am.
send the notes of algebraic identities. I'll give some identities to you. And
Okay, ma'am.
tomorrow, next class, when you come, you have to study those identities and complete. Okay, shall I wind up the class?
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you,
Okay,
ma'am.
Thank you, ma'am.
study well. Okay.